Okay, I asked people now, in the last 10 minutes of class, to write down step by step how they would solve a problem of this nature. And I got pretty good stuff, because people are doing pretty well with this, okay? So, taking what I saw and what I think, which is very close to what I saw, and I made a few comments as I went around the room about who said what, and how it might be modified a little bit or expanded, but again, what you did was great. But we sketched the normal curve for the z-value. That's our first step. Once we have a mean, a standard deviation, and some information about where things ought to be on the x-axis, we start by sketching our z-curve, which looks like this. Okay? Then we label our x values. Okay? So, we label the x values. So, at that point, we better label this z so we know that's z, and then we put an x here, and we put our numbers. Now, not using the numbers on our table. Maybe this is 110, this is 140. The mean is 100, well, the mean's got to be, if this is 110, this is 140, you've got to have 170 here, 200 here, and 230 here. Okay, well, that might be for a different situation, okay? Shade the region you need to find and estimate its area. Now, in the case of the example we just did, we had an x value that was about here. We shaded everything to the right because that was the area we chose to use to make the determination for the question that was asked. In general, you could have two x values. Maybe they'll be on the same side of the picture. What else could you have? You could have two x values. Well, that's a nice normal curve, but you have two x values on different sides of the middle. Okay? If you got two x values, they're going to be in the same side or they're going to be in different sides. Now, in the case we just did, let's try to draw a decent normal curve this time. We had all our x values on one side, and we were looking at the area, just all the area on that side of the x value. And of course, the one we drew, the x was on this side, and we were looking at the area over there. Or maybe we have a curve like this, and our x value is here, and we want the area to the left. Okay? Now, when we look up the area on the z-table, okay, well, we'll get two areas in this case. We'll get the area of this part here that isn't part of what we're looking at, and then we would also get an area between here and here that I'm not going to try to shade because it's going to obliterate the shading of the red. But we understand that. We've done these examples. Okay? Over here, well, this is just going to divide into two areas. The z-table will give us this area, and the z-table will give us this area, and they'll add up to the total area. That's the kind of situation we just saw. Okay? If we want everything to the left of some value, well, actually, it's not the situation we just saw here, because this ends at this x value, right? So we have two regions. Neither one of them is 50%. Now over here, one of our regions is the 50%. Okay, we got 50% over here, and we got an area on this side. Well, the z-table is going to give us this area, then we're going to have to know what to do with that, and it's obvious that that would be added to the 50% we have here. And what if we have this situation? Well, the z is going to give us this, and everything to the left of here is 50%, so we're going to have to subtract this area from 50%. So you always have to know what it is you're looking for so that you can draw the picture and get that straight before you start looking up things on the z-table. Okay? So, number 3, I say you shade the region you need to find and estimate its area. Okay, now, in every case you can estimate the area. You know, that looks like about 40%, that looks like about maybe 60%. This looks like, well, everything to the left of here looks like it might be 70%, 80% even. And everything to the left of here looks like it might be about 20%. That doesn't be my estimates for the purple regions that I originally shaded. You could make your own and make a better picture than I did because I just drew a quick schematic. You shade the region you need, and then you estimate its area, and do this before you ever look at a z-table, and I say do it before you ever even figure out your z-values. Okay? Because right away then, you've got a picture of the situation, then you can refine it. Now you've got the picture labeled, so you can figure out the z-value. If you know what this number is, you know the x value of this number, you can figure, and the standard deviation, you can figure out what z is here, and you can do the same thing, figure out what z is here. Okay? So, you find the z-values. That is the next thing you do after you estimate the area. You've done everything. Now you've got to find z-values so you can use the table to get an accurate result. So you find, excuse me, the z-values for the given x values. You shade the regions that will correspond to the areas given by the z-table. Now what do I mean by that? I mean, okay, over here we've got some region between two of these things, so we shade that region, and then we got the rest of the curve, right? And you find the z-values, and, well, this is what you do when you estimate, okay? Then you find the z-values, and you sketch the regions that will correspond to the areas given by the table. That would be, now, this region, and this region. The regions between the middle and your various z-values. You sketch those regions and calculate, and you find their areas. You look up the areas in the z-tables. Then, depending on what situation you have, you use common sense to find the area you need. And if your common sense is working, the area you need is going to come out reasonably close to your estimate. Okay? So if you have an estimate of 70%, and when you calculate your z, use your z-values and calculate what you think is the right answer, and you end up with 12%, you know there's something seriously wrong. If you can see from the z-table that this is at least 50% of the total area, it really looks like it's at least 50%, and you do the wrong thing with your z-values, and you come out with 20%, you know that you need to think a little bit more about either your estimate or how you calculate, how you use your areas that you got from the table. So, if your estimate isn't reasonably close to your final result, debug. Chances are your estimate is going to be more accurate than your final result if you screw up your calculation. Okay, but maybe not. Maybe you just made a bad estimate and it really is what you calculated. Well, you got to have enough common sense to figure that out. And if you do, then you have pretty good common sense, okay? So, that's the procedure. That's very close to the procedure everybody wrote down. The one thing I emphasize again, estimate before you look up the areas on the z-table. If you don't do that, you don't have the means to debug. You don't have as high a chance of getting it right.